Looking at figure 1 here, determine the size of the force W due to the suspended object and the tension T in the supported wire. Pay particular attention to scale and units. So that seems to suggest you're going to solve this by drawing it. Now that's difficult for me to do here, but I've drawn this triangle. If you like, you see this 300 force, 300 newtons here. That has to be balanced out. For this thing to be stable, T and W both combine to balance out 300, so they form a triangle. So I've slid back, if you like, the 300 newtons is acting across this way here. This is our 300 newton force, and you could represent that by drawing it on graph paper, 3 centimeters or 3 boxes. Now that's 1, that's 2, and that's 3 centimeters across. And then for this angle here to be, so you know, you could rough sketch it first anyway, but this force there, that's T going that way, and pointing down this way is W. So that's going to be 30 degrees, and because this is a right angle down here, over here we're going to have 60 degrees, because 60 and 30 is 90 and 90 is 180, the three angles inside. Now you can draw that with a protractor and a ruler, and you just keep the base at 3, keep this angle at 60, and these two lines will intersect up here, and you can check your angle as 30. And now it's just, you're going to measure, because 1 centimeter will equal 1 centimeter will equal 100 newtons, because 3 centimeters equals 300 newtons. So you'll draw this out, and then you'll measure the distance here, and whatever that distance is in centimeters. So for example, if you got 5 centimeters long, well, that would mean you'd have 500 newtons. And you're expecting this one here, T, to be the biggest, it'll be bigger than W because it's longer, it's the hypotenuse. So maybe you could get something like 6 for that, and you'd end up with 600 newtons. And that'd be your answer. You'd have determined, we need a direction of such a force. If you were now asked to calculate the equilibrium force, state the size and direction of such a force. Oh no, I'm reading the wrong question, sorry. On the wrong screen there. And attention T, yeah. So, no, yeah, we don't need the direction of those forces. That's kind of self-evident, I suppose. We need the forces in newtons. Now, there is another way of doing it, and I'm going to do it that way. This is kind of a more advanced way, which you probably don't need to know at this point. But looking at this triangle, that's the hypotenuse there. This is a right angle triangle. That's the hypotenuse. From the 60 degree, from this point, from this angle here, this here is the opposite side, which leaves the 300 known as the adjacent, ADJ. Right? Now, tan 60 degrees, tan is equal to the opposite divided by the adjacent. So tan 60 degrees equals W over the adjacent, which is 300. Multiplying both sides by 300, 300 times tan 60 degrees equals W. So I'm going to bang that into the calculator. 300 multiplied by tan 60, and I get 519. So I get W equals 519. The two decimal places 0.62, and that's going to be newtons. Now that's what you should go when you drew it out. You're going to get slightly over 5 centimeters if you keep a centimeter for each. That's their scale there. You could have marked that there as that's the scale, right? Because he wants you to pay particular attention. So 1 centimeter is 100 newtons. That's the scale of that drawing, if you like. Now, to get T, we need something with the hypotenuse. So cosine 60 would be the one we go with there. So I'll just go over up here on top, right? Cos 60, cosine carrying a harp, right? Two old angels sailing over heaven carrying a harp. That's adjacent over hypotenuse. So cos 60, I can look up cos 60 now, like cos 60 is a half, so you can say that a half, 1/2 equals the adjacent, which is 300, over the hypotenuse. We call that T. We're looking for T. So we can bang the T up there and bang the 2 up there, so we get T equals 2 multiplied by 300 T equals 600. And that's the length of T, that's the magnitude. In this case, that's going to be newtons. So you should get 6 centimeters there. So when you're drawing your triangle, that's another way, a more advanced way of doing it, I suppose, using the trigonometry. So that's about it. Let me know what you think of that. Thank you.